Hello again. So this is section 6.4, inverse trigonometric functions and right triangles. So what we're going to look at in this section is how can we actually find missing angles? So we're going to figure out ways that we can actually use these inverse trig functions to help us find the missing angles in a right triangle. All right, so we have an inverse sine, an inverse cosine, and an inverse tangent function, right? So an inverse function for each of those three main trig functions that we've discussed already. The sine, cosine, and tangent functions have to be restricted on their domains to be able to even have an inverse function. So sine, we're going to restrict to negative pi over 2 to pi over 2. Cosine, we restrict from 0 to pi. And then our tangent function has to be restricted from negative pi over 2 to pi over 2. And notice here with the tangent, the only difference between that and sine is we're not including those endpoints, right? So that's what those parentheses mean there. Okay. So our inverse functions, once we do that, the domain of our inverse sine is going to be from -1 to 1, meaning we can only substitute values from -1 to 1 into an inverse sine function. The range, though, the output values are going to be values between negative pi over 2 and pi over 2 now. Okay, so whenever you take an inverse sine, you should only get values that are somewhere between negative pi over 2 and positive pi over 2. The inverse cosine domain is the same as inverse sine. We can only substitute values between -1 and 1, but our output values now are going to be somewhere between 0 and pi instead. So you're always going to get values in that first or second quadrant between 0 and pi. The inverse tangent, our domain is actually all real numbers. We can put any value we want into an inverse tangent function, but its range, its output, is always going to be between negative pi over 2 and pi over 2, similar to inverse sine. But again, the only difference being that we can't actually get negative pi over 2 and pi over 2 now. Now, another name for each of these is we could just put arc in front of each of the trig functions. So the inverse sine, also known as the arc sine, inverse cosine, or arc cosine, and then the inverse tangent can also be called the arc tangent. All right, so example 1, we want to find exact values for each of these functions. So the first one we're looking at is the inverse sine of square root of 3 over 2. So basically what we're doing now is we're working backwards and we're trying to figure out what angle would give us a sine value of square root of 3 over 2. And so we can use that chart that we looked at earlier to help us find these values. And so we're looking at our chart and we're saying which of our angles is going to have a sine value of square root of 3 over 2. And if you look there in radians, that's going to be pi over 3. Okay, and keep in mind in this case, the inverse sine needs to be somewhere between negative pi over 2 and pi over 2. So just to kind of sketch out what that would look like, negative pi over 2 would be down here. Positive pi over 2 is going to be at the top up here. So we have to be in one of these two quadrants, and pi over 3 should be right here. Okay, and so pi over 3 does fit that criteria. It's somewhere between those two values, and so that's going to be our answer. Now, you could also do these in degrees, right? You'll see that we're going to do some of that when we actually look at some triangles. And so pi over 3 radians would actually be equivalent to 60 degrees. And so either of those answers would be fine. Just pay attention when you're working on homework to make sure that you're inputting your answer the way it asks for it. All right, now the next one says inverse cosine of -1/2. Okay, so in this case, we don't actually have a -1/2 in our table of values, but we do have a +1/2. So if you look at the cosine, where cosine is +1/2, that angle is actually going to be pi over 3. Okay, so the cosine at pi over 3 is actually going to give us a +1/2. Since we want a -1/2, though, we're going to have to move it to another quadrant. And keep in mind here that inverse cosine is always going to be somewhere between 0 and pi. So we have to be in one of those first two quadrants. Well, the only other place in the first two quadrants that cosine is going to be negative is going to be in the second quadrant. So we're going to use that reference angle of pi over 3 in our second quadrant, which means that our actual angle is going to be 2 pi over 3. And so this answer here should be 2 pi over 3 radians, or if you want the degrees, that would be 120 degrees. So again, if you ever have a value like this that's negative, that's not in the chart, think of the reference angle first, find the cosine that is 1/2, and then put that angle in the quadrant that would make it negative, okay, and then that should give you the angle that you want there. All right, and then finally we want the inverse tangent of 1. And so again, we can just look at our chart. Positive 1 has an angle of pi over 4, or 45 degrees. And again, we just want to make sure in this case that we're getting an angle that works in terms of the range of values that we want. And so we have negative pi over 2 to pi over 2 as our range here. And so we know that pi over 4 is in the first quadrant right here. And so that angle is between those two values. All right, now for the next one, it says to find approximate values of the given expression. And when we say this, we're looking basically to find these values in our calculator, because we're not going to be able to get exact values for any of these angles. So inverse sine of 0.71, we're going to go to our calculator. And in this case, we do want to be in radian mode. Okay, so make sure you've changed your calculator to radian mode. And if we do the inverse sine, the way we're going to get there is we're going to press our second key and then our sine key. So second sine should give you the inverse sine. Then we can just press 0.71. And when you do that, this should give us approximately 0.7895. Okay, and in general, you'll notice I'm going to round these to about 4 decimal places. Again, always pay attention in the homework to how many decimal places they're asking for. Now the next one, same thing. We're going to have to use our calculator because 2 is not a value from our chart. So we're going to do inverse tangent of 2. So again, we're going to do our second key, then our tangent key, and then we're just going to put 2. And if we do that, that should give us approximately 1.1072. Okay, and then finally, inverse cosine of 2. Okay, now, if you were to try this one in the calculator, what's going to happen is you're going to get an error. And it's going to tell you that it's a domain error. And the reason for that is, if you recall, our domain has to be somewhere between -1 and +1 for inverse cosine. Well, 2 is definitely not between -1 and +1. And so this one right here is actually undefined. Okay, so there is no solution to that, okay, because our domain is not correct for the inverse cosine. All right, now example 3, we want to find angle theta in the triangle shown. So we have a right triangle, we have our theta marked, okay, and so the first thing we want to do is identify, well, which sides are we actually working with? And so from theta, I notice here that the 10 is my opposite side, and then 50 is definitely the hypotenuse because it's across from that 90-degree angle. So since I'm dealing with opposite and hypotenuse, that tells me I'm going to use my sine function. So I'm going to take the sine of my angle theta, and I'm going to set that equal to the opposite over the hypotenuse, or 10 over 50. Now, at this point, this is where those inverse trig functions are going to come in handy, because now we can actually solve for that theta value. So what I'm going to do here, I want to get rid of that sine function to get my theta by itself. Well, the inverse of sine is inverse sine, or arc sine. And so I'm going to take the inverse sine of both sides of my equation now. Okay, and if you'd like to simplify the 10 over 50 to 1 over 5, that's perfectly fine. We're going to end up using a calculator anyway, and so it really doesn't matter if we simplify that first. All right, now what's going to happen over on the left-hand side is our inverse sine and our sine are going to cancel each other out. And so that's going to leave us with theta. And so now on the right-hand side, we have the inverse sine of 10 over 50, and we can actually just go to the calculator and find that value. In this case, because we're actually looking at a triangle, we probably do want this one to be in degrees. It probably makes more sense to think of it that way. So switch your calculator over to degree mode. And when we do the inverse sine of 10 over 50, That should give us approximately 11.5 degrees. Now, just so you know, if this was on a test and I didn't specify how many decimal places, right, then I would take whatever. Same thing if I didn't specify radians or degrees, I would have to take either or. But in the homework, just pay attention to which units they want because they will typically specify which units they want your answer in. All right, example 4. So a 40-foot ladder leans against a building. If the base of the ladder is 6 feet from the base of the building, what is the angle formed by the ladder and the building? Now, anytime we have a word problem and I can draw a picture, that's going to be my first step. So I'm going to start sketching out what we know. So we know we have a building. So I'm going to draw my building. And I know against that building, I have a ladder. So I'm leaning a ladder against my building. Now, the information that's given here is that the ladder itself is 40 feet long. So I know that the length of that ladder that's leaning against the building is going to be 40 feet. I also know that the base of the ladder is 6 feet from the base of the building. And so if I do that, I basically have this distance down here is going to be 6 feet. And so if you notice here, we formed a right triangle because we should have a right angle down here in the lower left corner. And so now the only question is, which angle are we actually looking for? So it says, what is the angle formed by the ladder and the building? So make sure you're putting your theta in the correct location. The ladder and the building is the angle up at the top now. All right, so now we look at the sides that are given and the angle that we're looking for, and we determine which trig function we're going to have to use. So since I'm looking for that theta up at the top, 6 feet is actually going to be the opposite side from that angle. 40 feet is going to be the hypotenuse. And so since we're dealing with opposite and hypotenuse, again, we're going to use sine this time. So this is going to be sine of my angle theta is going to be equal to opposite over hypotenuse, or 6 over 40. And then just like before, we need to get rid of a sign. So we're going to take the inverse sine of both sides of our equation. That leaves us with our theta. And again, we're going to go to our calculator because 6 over 40, even if you were to simplify it, is not a special value from our table. And so when we do that in degree mode again, this should give us about 8.6 degrees. So again, anytime you have a word problem like this and you can draw the picture, that's how I would start. The main thing here is to be careful about where you put your theta value. Always pay attention to the wording in the problem and make sure you're putting your angle in the correct location. All right, now number 5 says a lighthouse is located on an island that's 2 miles off a straight shoreline. Express the angle formed by the beam of light and the shoreline in terms of the distance d that's given in the figure. So if we look at our theta this time, we have the picture, we don't have to draw it. Theta's up in the top right-hand corner. That means that the 2 miles from the shoreline is going to be our opposite side. Okay, so we're given the opposite. And the d along the shoreline is actually going to be the adjacent this time. Because if you notice here, here's our right angle. So since we're dealing with opposite and adjacent, that tells us we're going to do our tangent function. So I'm going to take the tangent of theta, and that should be equal to opposite over adjacent, or 2 over d. Now, what we're asked to do this time is express the angle formed by the beam of light and the shoreline in terms of d. So I don't know how long that distance is. It's actually going to be changing as the lighthouse rotates, right? And so all we actually want to do here is just try to get theta by itself and get an expression that's in terms of d. So I'm just going to take the inverse tangent of both sides. My inverse tangent and tangent cancel out, leaves me with theta. And on the other side, there's nothing I can do now because I have a variable inside that inverse tangent. All I can do is leave that as the inverse tangent of 2 over d. Okay, so that is our angle expressed in terms of d now. All right, now number 6 says we want to find all angles theta that are between 0 degrees and 180 degrees that satisfy each equation. Now, to solve this, we're going to start the same way we would have before. So we have sine theta equals 0.4. To get rid of a sine, we're going to use our inverse sine. So that's our first step. Take the inverse sine of both sides. And again, 0.4 is not one of those special values from our table, so we are going to have to use a calculator here. And since it tells us 0 degrees and 180 degrees, we definitely want to be in degree mode this time. And so if we do that, our calculator should give us 23.6 degrees. So that's definitely an angle that's between 0 and 180 that would satisfy this equation. Now the question is there any other angle between 0 and 180 degrees that would also satisfy this equation? And here's what we have to consider. Sine, we know, is always going to be between negative pi over 2 and pi over 2, meaning we're always going to get a value that's somewhere in the first or fourth quadrant. Because now we're looking between 0 and 180 degrees, now we're actually looking in the first and second quadrants, and so there could potentially be another angle that's somewhere in the second quadrant that would work for this equation. And so that's what we have to look at now. So what I'm going to do is I'm going to take that 23.6, which we know is going to be right here in the first quadrant. And I'm going to think of that as a reference angle now, and I'm going to put it into the second quadrant. So I'm letting 23.6 degrees be the reference angle in the second quadrant. And if you recall, sine should be positive in both the first quadrant and the second quadrant, so it's possible that we would get a positive 0.4 from either of these angles now, and that's why we have to look for both. Now, the way we're going to find this larger angle is 180 degrees minus the 23.6 degrees. And if we do that, that should give us 156.4 degrees. So if we were to take the sine of 156.4 degrees, it should give us approximately 0.4. We've rounded, so it's not going to be exactly that, right? Okay, but 23.6 degrees and 156.4 degrees should both give us a value close to 0.4. And so our two answers here, 23.6 or 156.4. And again, the reason that we have two values this time is because the sine value in the first or second quadrant, since we're looking between 0 and 180 degrees, could be positive in both. Now, the next one, we're looking for a cosine theta equals 0.4. So we're going to use our inverse cosine. That's our first step. Again, we're going to go to our calculator to find that. And so when we do that, that should give us 66.4. And again, don't forget your degree symbol because we're in degrees now. Now the question is there any other angle between 0 and 180 degrees that would satisfy this equation? Well, 66.4 degrees, first quadrant, positive value. If we were to put this reference angle in the second quadrant, cosine in the second quadrant is actually negative now. And so that would actually give us a negative 0.4, not a positive 0.4. And so the only angle that's going to work for this equation is the 66.4 degrees. Okay, so it's only with sine, if we're dealing between 0 and 180 degrees, sine is the only time we have to worry about finding two different values. With cosine or tangent, because they're going to be negative in the second quadrant, we're not going to have to worry about finding a second value now. All right, now number 7 says we want to find the cosine of the inverse sine of 3/5. Now, keep in mind that anytime we're using an inverse trig function, what we're finding is an angle. And so the first thing I want to do here is I'm going to let theta be equal to the inverse sine of 3/5. So basically take everything inside that entire inverse trig function and let it equal some angle theta. So really, what we're trying to find now is cosine of theta, because I've let theta be equal to that inverse trig function. So what I want to do now is I'm going to use that equation that I created, that theta is equal to the inverse sine, and I'm going to take the sine of both sides. That way I can get rid of that inverse trig function altogether. So I'm going to take the sine of theta, and I'm going to take the sine of the inverse sine of 3/5, because the sine and the inverse sine should cancel each other out. So really this just says that sine of theta is equal to 3/5. Now, keep in mind, if we get a ratio for sine, we know that that gives us the opposite and the hypotenuse of a right triangle. So I'm going to draw my right triangle. I'm going to label my theta. And it really doesn't matter where you put theta in this case. Okay, so I'm just going to put it down in the lower right. And again, sine should give us opposite over hypotenuse. So my opposite side should be 3. My hypotenuse should be 5. Now, from here, we need to know that bottom side because we're ultimately looking for cosine of theta. So I need to know that adjacent side down at the bottom. Now, you might recognize this as one of our special triangles, and if you do, that's perfectly fine. Otherwise, we can use Pythagorean theorem. 3 squared plus b squared equals 5 squared. Well, 3 squared is 9. 5 squared is 25. Now I subtract 25 minus 9 should give us 16. And when we take the square root, b should be equal to 4. And so we have a 3, 4, 5 right triangle. Now, once we have all the missing sides of that triangle we created, again, what I'm looking for is cosine of theta now. So I'm just going to look at my right triangle. I'm going to find the adjacent side and the hypotenuse. And that tells me that cosine of theta is going to be equal to 4 over 5, which means that the cosine of the inverse sine of 3/5 is equal to 4/5. So again, anytime you see an inverse trig function inside of another trig function, let that inverse trig function be your angle. Use that then to draw a right triangle so that you can find any missing sides. And at that point, we're just evaluating the trig function on the outside for that triangle that you've drawn. And number 8 says we want to write the sine of the inverse cosine of x and the tangent of inverse cosine of x as algebraic expressions in x. And they're telling you here that x has to be between -1 and 1. That's just to satisfy the domain restrictions for our inverse cosine here. All right, now we're actually going to do this one almost exactly the same way that we did the previous one. The only difference now is we have variables instead of numbers. But our first step is I'm going to rewrite inverse cosine of x as theta. Okay, so I'm letting that inverse trig function be my angle. Now, since we're using the same inverse trig function in both, that means eventually I'm going to find the sine of theta, and I'm going to find the tangent of theta. Okay, so again, we're just letting everything inside here be our angle, everything inside this one be our angle. Now, just like we did before, I'm going to take the cosine of both sides in this case so that I can get rid of that inverse cosine. So now that tells me that cosine theta is equal to x. Now, because we just have an x and we don't actually have a ratio this time, I'm going to create a ratio. So just remember, if you ever just have a whole number or just a variable, you can always set up a fraction and put things over 1. So that's exactly what I'm going to do here, is I'm going to write that as x over 1. And now cosine should give us the adjacent and the hypotenuse for a right triangle. So I have my adjacent and I have my hypotenuse. So now I can draw my right triangle. Again, I'm going to use theta. I'll put it down here in the lower right. And since I'm given cosine, I have the adjacent and hypotenuse. The adjacent side needs to be x, and the hypotenuse needs to be 1. Now, the next piece is we need to find that missing side in our triangle, because once we have that, then we'll have everything we need to be able to find the sine of theta and the tangent of theta. So I'm going to use Pythagorean theorem here. X squared plus b squared equals 1 squared. And I'm looking for b because I'm looking for that missing side. So I'm just going to subtract the x squared now on both sides. So that's going to give us b squared equals 1 squared is just 1. So that's 1 minus x squared. And now to get b by itself, I need to take the square root. So we end up with square root of 1 minus x squared. And you might be tempted to try to simplify this. Just remember, with square roots, if there's addition or subtraction inside, we're not allowed to split that up. So square root of 1 minus x squared is as simple as that's going to get. So that's going to be our side over here, square root of 1 minus x squared. All right, and now that we have that, now we just want to find the sine of that theta and the tangent of that theta. So let's start with sine. Sine, remember, is going to be opposite over hypotenuse. So this should give us square root of 1 minus x squared over 1, or just square root of 1 minus x squared. So our sine of inverse cosine of x is equal to the square root of 1 minus x squared. All right. And then our tangent of theta, that's going to be opposite over adjacent. And so if we do the opposite over the adjacent, that should give us square root 1 minus x squared all over x. And so the original thing that was given, tangent of the inverse cosine of x, is equal to the square root of 1 minus x squared over x. Okay, so that's everything we've got for section 6.4. Again, as you're working on the homework, please let me know if you have any questions, and I will see you next time.